So I'll draw a dipole which is placed in a uniform electric field. So let us say I draw a dipole. Suppose this is a dipole, this is minus q charge, this is plus q charge, and suppose the electric field is like this. This is electric field E. This is the direction of electric field. So uniform electric field is there, means I should have drawn another lines also. There is electric field in this direction and it is uniform. Uniform means the magnitude of electric field is not changing at in a certain region. Actually in this region magnitude of electric field is not changing, so it is uniform. Now the axis of the dipole, axis क्या है? Suppose I write this point is A, this point is B, then AB is the axis. AB is the axis. So axis of the dipole makes an angle theta with the direction of electric field. From the definition of electric field, when I started, I wrote E, electric field is force per unit charge. So from that formula we can write that force is q naught times electric field. It means there will be force on this charge plus q and there will be force on this charge minus q, because both are placed in an external electric field. Both are placed in an external electric field. Please remember, this electric field E is not due to any of these two charges. This electric field E is not due to any of these two charges. So plus q will experience force in this direction. It will be QE like this, and minus q will experience force in opposite direction and it will be QE in opposite direction. So if we want, we can write minus QE. Now what will be the net force on this dipole? And we could write this point is O, and the distance between two charges we always take 2a. So again I am writing 2a. So what is the net force on this dipole? Net force. So net force, if you see, QE, this QE is acting in x-axis direction, this is acting in negative direction of x-axis. So both are equal and opposite. So QE and minus QE both will result to 0. So QE and plus minus QE, the result will be 0. So net force on this dipole is 0, and since the net force is 0, so there will be no translatory motion. There will be no translatory motion. We need to remember this. It means that is no translatory motion is possible. If you are not getting still, I'll again explain this term. Since force is 0, it means ma equal to 0. It means a is 0, and if a is 0, then v minus u divided by t is 0, or it can also be written as v equals to u, means there is no change in the velocity. So if the dipole is at rest, and obviously in this case dipole is kept at rest, so it will remain at rest. That means no translatory motion is possible if net force is 0. Okay, so after this, since force is 0, net force is 0, translatory motion is not possible. But if you see the diagram, lines of action of these forces are different, and I will draw those lines. For this lines of action, this is the line of action. For this force, this will be the line of action. So lines of action for both the forces are different. So lines of action of force are different. It means they are equal and opposite. Since lines of action of these forces means QE and minus QE are different. They are equal and opposite. Forces are equal and opposite. Forces are equal and opposite. So they actually are acting at different points, so they form a couple. Hence they form a couple. This thing we need to remember. Hence they form a couple. And movement of this restoring, and what is this couple doing? This is trying to bring the dipole, couple is trying to bring the dipole in the direction of electric field. Moment, if we calculate magnitude, it will be equal, mean torque. The moment of this restoring couple is known as torque. Moment of this couple equals to torque, and we know very well that torque equals to either force multiplied by magnitude of torque. I am talking about perpendicular distance between lines of action of forces. So here torque I am representing by tau now. Torque equals to what is the value of either force? Value of either force is QE. QE, both forces are equal. Remember, minus sign is just indicating direction, nothing else. So torque equal to QE becomes either force, and then the perpendicular distance. I want to know the perpendicular distance. So perpendicular distance निकाल लेते हैं. Let's go back to the diagram. Draw a line, perpendicular distance. This is line of action, this is line of action. This will be perpendicular distance. Which line? Let us say this point was B and I am saying this point is C. So BC is perpendicular distance. See the diagram. If this angle is theta, this will also be theta. So for this angle theta, BC is perpendicular. So perpendicular means BC. Perpendicular by hypotenuse means BC upon 2a equal to sin theta. So BC upon 2a equals to sin theta. BC upon 2a equal to sin theta. BC is the perpendicular distance, so QE into BC QE into BC. And the value of BC is 2a sin theta. So QE into 2a sin theta. So Q into 2a becomes P, PE sin theta. Value of magnitude of torque becomes PE sin theta, and unit of torque is Newton meter. So we will write the unit also, Newton meter. This is the value of torque. Now in vector form, in vector form, this torque is written as P cross E. Okay, so this is an important formula, torque equals to P cross E. So please remember, in uniform electric field, dipole experiences no force. Dipole experiences no force, but torque acts. And maximum torque maximum can be equal to PE. एक बात और मैं ध्यान दिला दूं यहाँ पर कि नेट फोर्स ज़ीरो है, एक्सपीरियंसेस नो फोर्स, बट ओनली इन यूनिफॉर्म इलेक्ट्रिक फील्ड. सो if electric field is not uniform, if electric field is not uniform, if E is not uniform, then net force will not be zero. And there will be translatory motion as well. Now torque equals to P cross E means we can write down PE sin theta, magnitude form. Now if theta is 0 degree, then torque equals to PE, because torque equal to PE into sin theta means 0, because sin 0 की वैल्यू 0 होती है, so torque will be 0. If theta is 180, then also torque equal to PE into, because sin 180 की वैल्यू भी 0 होती है, so it will again be 0. This condition, when theta is 0, this is termed as stable equilibrium. Stable equilibrium. This is unstable equilibrium. अब अनस्टेबल और स्टेबल इक्विलिब्रियम क्या होते हैं? स्टेबल इक्विलिब्रियम और अनस्टेबल इक्विलिब्रियम क्लास 11th में जब टॉर्क चैप्टर, जो रोटेशनल चैप्टर पढ़ाया गया था, तब बताया गया था. फ्री में दोबारा याद ले रहा हूँ. स्टेबल इक्विलिब्रियम वो इक्विलिब्रियम है अगर कोई बॉडी स्टेबल इक्विलिब्रियम में है अगर, और उसको हम डिस्टर्ब करें, तो वो डिस्टर्ब होने के बाद इट रिटेन्स, आफ्टर सम टाइम इट रिटेन्स इट्स मीन ओरिजिनल पोजीशन. अगर एक बॉडी एक इक्विलिब्रियम पोजीशन में रखी है और हम इसे डिस्टर्ब करें, तो डिस्टर्ब करने के बाद जैसे ही हम फोर्स हटाएंगे उस पर से, डिस्टर्बिंग फोर्स जो भी हमने लगाया था उसको डिस्टर्ब करने के लिए, उस फोर्स को जैसे ही हम हटाएंगे वो वापस अपनी ओरिजिनल पोजीशन में आ जाएगी. अनस्टेबल इक्विलिब्रियम में क्या होता है कि अगर हम कोई फोर्स लगाएं उसको डिस्टर्ब करने के लिए और फोर्स हटा दें, तो बॉडी अपनी वापस उसी पोजीशन पर नहीं जाती है जिस पोजीशन पर बॉडी थी. जबकि पहले इक्विलिब्रियम लग रहा था देखने में, लेकिन वो दोबारा उसी पोजीशन में वापस नहीं जाती है. तो इट